So good everyone. In today's session, we're going to learn how to solve a linear program using the Excel. So we have a question here that we'll be solving. Yeah. And then in our previous section or in a previous video, we learned about the kind of things you need to look for when solving for a linear programming. That's the component of a linear programming, if I'm right. And we said these components, we have four. It includes the decision variables. First of all, we look for decision variables. We look for your objective function. The objective function. And then our constraints. And we said that these constraints include, and we have our non-negativity constraints. We will add it as a non-negativity constraint. Okay. And then we said our decision variables talks about the things that they are producing if they are doing with production. The decision variables are the things that they are producing. So assuming for this question, I'll talk about it. And then we said our objective function is the main reason why they are doing the production. What they are producing. Are they producing to maximize profit or they are producing to minimize cost? There are constraints. For here, I would say the constraints are the resources that they are using. Things that contributes to their objective function. Right. And then the non-negativity constraints, it talks about them not like the thing that you are producing or your objective function. Or let me say your decision variables cannot be zero, cannot be negative. Your decision variables can never be negative. What you are trying to say is that we are producing goods. So it's either we produce or we don't. If we don't produce, our variables is equal to zero. That's we didn't produce anything. But if we produce, then our variable is going to be greater than 1. Or it's going to be 1 and more. Because it's either we produce 1 or we produce more. Or it's either we don't produce at all. So our decision variables is either going to be 0 or more than 1. That's why we say non-negativity, because you can't tell me that we are producing mango and then today we produce negative 1 mango. No, it can't be possible. It's either we don't produce at all or we produce more than 1 or 1 and above. So this is the components or the thing that you need to take note when solving a linear programming question. So let's read this question and then start solving it. So we said we are taking note of our decision variables. Decision variables 1. We have our objective function, the constraints, and then the negativity constraint. Okay. So this question says Romeo and Juliet in comparison make different delicious cakes for all ceremonies as required by clients. The most demanded cake by clients this session include combination of chocolate cake, white bread, and sugar cakes. Currently, stocks at the store include 150 bags of flour, 105 bags of sugar, and 3 dozen eggs. Which are the 3 main ingredients required for baking? The required number of flour to bake chocolate cake, white bread, and sugar cookies are 5, 8, and 3 bags respectively. Meanwhile, due to scarce of sugar, only 18 bags of sugar, 25 bags, and 22 bags of sugar is required for chocolate cakes, white bread, and sugar cookies respectively. Special cakes for Romeo and Juliet in comparison requires that 8 eggs will be needed for chocolate cake, 5 eggs for sugar cookies, and 6 eggs for white bread. The desired baking time requires 3 hours to complete cake preparation, and baking with 45 minutes required for chocolate, 45 minutes for white bread, and 20 minutes required for sugar cookies. Chocolate cake is expected to be sold at a unit price of 65, the white bread for 75, and the sugar cookies for 55. So this is the preamble, this is the problem that we need to solve, or this is the question that we need to solve, right? So now we are done reading the question. We'll go through it again, and then as we are going through, we'll be taking note of these things, the components, that's our decision variables, our objective function, our constraints, and non-negativity constraint. And since we are producing, they say they produce cakes, delicious cakes. So as they are producing, their main objective is to maximize profit. As a production, your objective is to make profit. So we know our objective function, that our objective function is to maximize profit, and this can be represented by Z. So now we have to look for our decision variables, and I said earlier that your decision variables talks about the things that you produce. So 4, 2, 3, say for the decision variables, we're talking about the things you are producing, right? So let's go into the question. Look at the things they are producing and make those things are their decision variables. So they said Romeo and Juliet Incorporation makes different delicious cakes for all ceremonies as required by clients. The most demanding cakes by clients this season include combination of chocolate cake, white bread, and sugar cookies. So these are the three things that they mentioned that clients are demanded, which means they produce those things. So we know that Romeo and Juliet produces chocolate cake. So let me write it. They produce chocolate cake, right? And then they produce white bread, and also they produce sugar cookies. So sugar cookies. So these are the three things that they produce. So in our previous video, we said the decision variables represent them by that's why we said decision variables. So we represent these things that they produce by a variable. So normally we say let x1, x2, and x3 represent these goods that they produce. So we say let s1 represent the chocolate. So x1 to represent this chocolate cakes, s2 to represent this white bread, and then s3 to represent the sugar cookies. But they are not just representing the sugar cookies or the white bread or the chocolate cake. They are representing the number of chocolate cake they can produce or they can sell to their clients. The s2 is representing the number of white bread that Juliet and Romeo can produce, and then the s3 is representing the number of sugar cookies. So we don't just say we are representing s1 for the chocolate for let s1 represent the chocolate cake, let s2 represent white bread. No, s1 is representing the number of chocolate cakes that they will produce or they were able to sell to their clients. So now we know our decision variables, we know our objective function. Let's talk about the constraints. So we said the constraints are the things that contribute to their objective function, or it contributes to their decision variables. So here we know that these are decision variables. We are saying that let s1 represent the chocolate cake. So what we are saying that the constraints, they are the things that were involved before you can arrive at this chocolate cake, before we can arrive at this white bread, and then arrive at this sugar cookies. So what are the things that they use? So the constraints usually talks about the resources that contributed to the thing that they were able to produce or the thing that they produce. So it could be an ingredient, any resources, maybe a contributing. So first of all, you look at the things that they are producing. This talks about your decision variables. If they are producing, then you know your objective function. And then as you've been able to identify the things that they produce, you now look for the things that aid in the production. So those things that aid in the production, this becomes your constraints, right? So let's continue reading the question. So we've been able to identify the things that they produce, and then we said they produce chocolate cakes, white bread, and then sugar cookies. And they say currently stocks at the store include 150 bags of flour. So they say their stocks include 150 bags of flour. They have 105 sugar, and then 3 dozens of eggs, which are the 3 main ingredients for baking. So here they are telling you that their ingredients for baking is this bags of flour, the sugar, and then the dozen of eggs. So now we know the thing that they use for their baking, their ingredients, and then we've already talking about it that this ingredient consists of the constraints, right? So we can write, you can jot it somewhere that the available resource that they use 150. So for the constraints, they use 150 bags of flour. So let me do it flour here. Flour. So they use 150 bags of flour. They use 10 bags of sugar, and then they used 3 dozens of eggs. So eggs, that's 3 dozens, right? And then okay, so we'll talk about this later. They said the required number of flour to bake chocolate cake, white bread, and sugar cookies are 5, 8, and 3 bags. So here they are telling you, they are giving you more details about the number of flour they used, like this ingredient. They're not giving you details about the number of ingredients they use in producing each of their cookies, right? So they said, let me use red here. They said that they require the required number of flour to bake chocolate cake. So they are talking about chocolate cake. They say white bread and sugar cookies are 5, 8, and 3 bags respectively. Respectively means this 5 is for the chocolate, this 8 is for the white bread, and this 3 is for the sugar cookies. So what they are saying is that the flour, out of this 150 flour, they use, so let me write the flour here. Out of this 150 flour, they use 5 for chocolate. So let me write C for chocolate here. They use 8 for white bread. So let me represent white bread with W here. And they use 3 bags for sugar. So let me represent sugar by X here. So 3 for sugar. This is how they apportion it. Out of this 150, this is how they apportion for the flour. And then they said, meanwhile, due to scarce of sugar, only 18 bags of sugar, 25 bags, and 22 bags of sugar is required for chocolate cake, white bread, and sugar cookies. So this one too, they were talking about how they apportion the number of sugar they have with in order to bake the chocolate, the white bread, and then the sugar cookies. So they are saying that because the sugar is very scarce, sugar and loss, they only apportion 18 bags of sugar, 25 bags, and 22 bags of sugar cookies for chocolate cake, white bread, and sugar respectively in order. So the 18 is for the chocolate cake, the 22 is for the white bread, and then the 25 is for the white bread, and then the 22 is for the sugar cookies. So let's write our sugar here. How they apportion the sugar. They said 18 for chocolate, so C for chocolate, so let's write 18 here. They said 25 bags for white bread, so you have 25 here, and then 22 for sugar cookies, so you have 22 here. So this is how they apportion this 105 sugar. This is how they apportion it when producing the chocolate cake, the white bread, and then the sugar cookies. They went further and said special cake for Romeo and Julia Corporation requires that 8x will be need for chocolate. So here they said they go straight by saying 8x for chocolate. So let's write egg here, and then we said chocolate 8. So they needed 8 for chocolate, and then 5x for sugar cookies. So these are sugar cookies, so they use 5x, and then 6x for white bread. So 6x for white bread. The desired baking time require 3 hours. So they said they use 3 hours in producing this. So let me add the time here. So the time also becomes part of their resources. So they use 3 hours in producing these cookies. So they said 3 hours to complete cake preparation and baking. So with 45 minutes required for chocolate. So they use 45 minutes to prepare the chocolate. So let's write our time here. So time. They said they use 45 minutes to prepare the chocolate. They use 35 minutes to prepare the white bread. So 35 for white bread. And then 20 minutes required for sugar cookies. So 20 minutes for sugar cookies. It's a chocolate cake is expected to be sold at a unit price of 65. So now they are telling me the price they sold the chocolate. So they said they sold the chocolate. Let me scroll it here. So let me write the price here. They said they sold the chocolate for 65 cedis. So 65. White bread for 75. So white bread for 75 cedis. And then sugar cookies for 55. Sugar cookies for 55. And then the main question was to find the maximum. If the company or Romeo and Juliet want to maximize their profit, what were the objective function? Like what's their profit? Profit but not maximize here. How much did they make? Right. So we are done gathering the information. These are the information needed. So what we are going to do is that we have to represent them in a linear form, in a linear programming model form, where we tell them our objective function, our decision variables, and our constraints. So first of all, we talked about our decision variables, and we said this. We told them we are representing it by x1 and x2 and s3. Here is it. So we say let x1, x2, and s3 represent the number of chocolate cake, white bread, and sugar cookies produce respectively. After you are done with this, we write the objective function. What's our objective function? So objective function was to maximize profit. So we say objective function was to maximize profit. So this is Z. How do you maximize profit? This is the price. Here they said the price is 45, 65, 75, and 5 cedis. Was it 5 cedis? 55 and 55. Yeah. So what they are saying is that when you sell each product Biana, when you sell chocolate, you get 65 cedis. When you sell white bread, you get 75. When you sell sugar cookies, you get 55. So for you to maximize your profit, how do we get profit? The profit is the number of chocolate cakes we can sell multiplying its price. So assuming we can sell 5 chocolates today, we can sell 5 chocolates, and one chocolate is 65 cedis. Plus, if you can sell like let me say 12 white bread, it's multiplied by 8 amount, and then if you can sell let me say 10 sugar cookies, it's multiplied by 8 amount. So when you add all this, when you multiply this amount by this by this by this, and you add everything, that will be your profit. That's the profit you're able to make after selling all these things. So we said our profit Z is the function is 65. That's the price of the chocolate cake. And then we said let's represent it by this decision variable is x1. We don't know the number of chocolate drink that we will be able to sell. So plus 75 s2. That one we don't know the number of white bread we are going to sell. This is 65 s3. So this is your objective function. We move to our constraints. So we say this is subjected to the constraints. So the constraints, we have sugar. Let me take them one by one. So we have flour. Let's take flour first. So we have flour, and then flour, they said their portion is 583. That's 5 for chocolate, 8 for white bread, and 3 for sugar cookies. So 583. So 5, and then our x1 plus 8, or x2 plus 3, or s. So that's 5 for chocolate, 8 for white bread, and 3 for the sugar cookies. And then here they said the flour available was 150. So they had 150 flour available. So what we are saying is that it's either they use all or they didn't use up to the amount of flour that was available. And we don't know the quantity they were able to produce. So we say it's less than or equal to the total amount of flour, which is 150. So the available resource for the flour was 150. So it's either you are going to use all the 150 or use less than the 150, right? So our next ingredient was sugar. So let's write our sugar here. And then we have 18, 25, and 22 respectively. So we have 18 x1 plus 25 x2 plus 22 s3. And then the available resource was 105. That's the sugar they were using. So it's either they use exactly everything or they use lesser than that. So 105. Our next constraint, our next ingredient, we have egg. So we have egg here. How did they use it? 6, 8, 6, 5 respectively. So 8 for x1, 5, 8, 6, 5 here for x2, and 5 for x3. That one too. We said 3 dozens of eggs, and then we know that 1 dozen is 12. So 12 times 3, that will give us the total eggs they were having. So 12 times 3. So you have 36. and then the time. So you have our next resource is the time. So you have time here. So how did they apportion it? They said 45 minutes, 35 minutes, and 20 minutes respectively for them. So you write out 35 minutes. So 35 minutes, 20 for the second one, and then so 35, sorry, 45, 35, and 20. So here is 45. This one is 35. This is 20. Let's check the time too. It says the time is 3 hours. And then they were given in minutes. They said they use 45 minutes, 35 minutes, and 20 minutes. And this is 3 hours. So we have to convert these hours into minutes. So we say 3 times 60 because we know that 60 minutes make 1 hour. So we convert and then you write it. And then since they were not able to consume all the time, it's either they consume all or less, right? So you write it. Which we get 180. So we are done with our constraints. Yeah. So what you have to write is our non-negativity constraint. So we say our non-negativity. Our non-negativity constraint, which is what we are saying is that our variable x1, our variable s2, and our variable s3 should be greater or equal to 0, which means we can't have negative. Our s can't be negative. It's either we produce or we don't produce at all, right? And if you don't produce, it's not negative. So this is your objective function. You have your objective function here. Let me use red. So we have our objective function here. We have our constraints. So these are our constraints, right? And these are non-negativity constraint. So we have to represent this on Excel. We have to represent this on Excel and then solve it using the Excel. So let's break this one too down. Or let me explain it so that you know how to represent it on Excel. On Excel, we are going to break it down into this is the price and this is the variable, like the quantity. So we know that when we multiply the price by its quantity and we sum everything, we get the profit. And when we come to the constraints too, each constraint or each resource is comprised of two things. It's comprised of the product that we are producing or the quantity of the products we are producing, which we can represent by this quantity, and that's the coefficient of the number of flowers they use. The number of flowers they use, right? Okay. So on Excel, we are going to break them down by here. When we talk about the maximum, we talk about the price, or when we talk about the profit, we talk about the price, and we talk about the quantity. And we know our profit is our price multiplied by our quantity. That's our price when we multiply by the quantity. When we talk about the constraints too, when we take flour, we know we are talking about the quantity that was used, and then the coefficient is the coefficient, right? Or the number of flowers, how they apportion the flowers to the things they were producing. So this is how we are going to group it. So when we get to Excel, I will explain it further and then you will understand what I'm trying to say. Okay, so let's move to our sheet. This is our sheet. So we have to present all the information that we had here. And then we said the maximum, first of all, we talk about the objective function. It consists of the price and then the quantity that we are able to produce. So making things simple, let's group them into, you see, we are producing 3 different things. We produce chocolate, what? We produce chocolate cakes, white bread, and sugar cookies. So let's write our chocolate cake here. So we have our chocolate cakes. You move to the next tab. You click. You type your white bread. The next tab. You type your sugar cookies. Yeah. So you add it. Okay. And then our sugar cookies. Okay. So we said write your quantity here. Quantity. And then your price here. So what I was trying to say is that, you see, to get your profit, it was your price multiplying your quantity. And then we had the quantity, the price. For chocolate, they said it's 65. For white bread was 75. And then for sugar cookies was 55. So here is the quantity. And since we don't know the number of quantity will be produced or the number of quantity we can sell, represent it by 0. So here to be 0, here is 0. Therefore, we can say our to maximize profits, you can say our maximum, or you can say profit, right? So maximum profit, let me write profit here. Normally represented by Z, variable Z. So we don't know. So we are now finding for it. Let me expand this one. Yeah. So we are now finding for Z. So this our Z will be the multiplication of this, the quantity that we have here, multiplied by this. We add it to the quantity we had here, multiplied by this, plus the quantity we have here, multiplied by this. So this is our objective function. When you are separating, you are group it into two, into the price and the quantity. Then we move to our constraints. So the first constraint was a flour, the resources that we use. We have flour here, we had sugar, and then we had our egg, right? Yeah, I think time too was part of our resources. You can see time or duration, how you want to say it. So for the flour, they said they use 5 for chocolate, 5 resources for chocolate, and then they use 8 for the white bread, 3 for the sugar cookies. So here, let's write that our available. Let's write usage, the number of things we use. So our usage will be here, and then our available resources. I'll explain everything. Available resource, right here. Okay. So let me expand this. Let me do it. So available resources is here. So the resource that was available was 150. So we use 150 resources. And then the sign here, we said we don't know. They were not specific. So it's either we use less or we use exactly the 150. For the sugar too, the available resource was 18. They are portion 18 for chocolate cookies. They are portion 2 for white bread, and then 22. Yeah. So the same thing. You never know the amount. And then 105 is how far they used. When it comes to egg 2, egg was 8. 8 eggs um, by 6 and then 5. Uh, sugar here is 25. 25. Yeah. And 36. Then it comes to the time. So the time we have 45 minutes. We have 35. And then we have 20 minutes. And they said the total time was 180. Okay. So we are done inputting or representing it in an Excel. Let me explain this. So to know the usage, how the number of flour that we used, we are saying that it's a summation of all how they apportion the flour multiplied by the quantity they used. So we say this 5 multiplied by the quantity. This is the x, the decision variables only representing our zero. So these are the decision variables. So we say this the 5 multiplied by the number of things they were able to produce plus this 8 multiplied by this multiplied by this. So the same happens for everyone here because it's 5x1 and this is the x. So this represents the x1. The 0 here represents the x1. This one represents the s2 and this represents the s3. These are the quantities that we did. So if you say 5 multiply x1, like how we did it for the flour, 5x1 plus 8x2 plus 3s3, it's less than or equal to 150. Same thing, 18x1 plus this plus this is less than or equal to 105. X2, we had the same thing. You understand? So we create it here. But then we don't know the variable. We are finding for the number, the quantity, the x1, x2, that's the decision variables. We are finding for them. And since we don't know the number, we represent them by 0. Okay. So that we solve it here and then we know the quantity they're able to sell. So we say our decision variables, our maximum, our profit. We came with a formula, or the equation was this 65 multiplied by this variable plus 75 multiplied by this variable plus 55 multiplied by this variable. So you say we input our formula to get the maximum profit. We said the sum product. So the sum product of this. Why didn't it appear? Is it because I'm writing? Um, so we say it's equal to the sum product. I did the sum. Okay. The sum product. So this is the sum product. The sum product simply means the addition, you adding something and that same thing being multiplied. So we are adding this, and then as we are adding, we are multiplying them too as well. So we say this quantity, you bring your comma by this quantity, by the price. So we are saying that the sum product, since the formula was 65x plus 75x2 plus 55x3. 65x means 65 times x, right? So that's the product you multiplying. 75x2 means 75 plus times x2. 55 x3 means 55 times x3. And then we did plus plus plus, as you can see how the formula was. So we said the sum product of the quantity by the price. So that's why we had the sum product of this quantity, and you bring a comma, the price. So you do the same here, the sum product, right? So this is the sum product. So the sum product of this is the quantity, that's the x. So comma, and then the coefficient of the flour. Click or enter, you put the same formula for sum product of quantity, comma, click and hold and drag. So sum of the x, when you type the formula, you have to close this bracket. So if you own the bracket close is not there, you have to close it before you click on enter. Same thing, equal to the sum product of this, comma, by the quantity. Okay, so we are done inputting the formula. So now our profit is the summation and then the product of the quantity by the price. When it comes to our sugar, our flour, now the formula is the sum profit of this quantity, because it's quantity and then the coefficient and then the quantity. So this quantity and then how they apportion the flour for each of these things that they're producing. So we apply the same for everyone, like all the constraints. Then we go for our solver. So when you're using Excel, your solver will be at this data. You see your solver here. Data, your solver will be here. But this is different thing. So this is my solver. So I think the time here was 45, not 35, not 25. So here's 45. That's one. That means this formula. Okay. So let's input the solver. So objective function, the target cell, the cell that you're targeting is our maximum. That's objective. So what are we to do? We have to maximize profit. By changing cells, we are changing the quantities, the decision variables. That's our changing cell. The cell reference, the operation, and then the value talks about the usage, the sign here, and then available resources. So let's enter our constraints here. So we select this one. The signs are the same, less than or equal to. We come to the value, that's the available resources. So we select this one. Why is the sign? Okay. So we select this one. Yes. So let's do it like that. One last constraint, last but not the least. This. I remember we said the our last one was the non-negativity constraint. So the non-negativity, we said the variable, the C variable, that's the S1 and S2, S3, should be greater or equal to 0. So here you just click on 0. Yeah. We generate a sensitivity report. Okay. So for those using the Excel, the method use the simplest method, and then you click on generate sensitivity report, and then you solve. Okay. So this is the answer that we are going to get. So as you can see, our quantity is now 1.66667 for chocolate cake. The white bread is 3. The sugar cookies is 0. When we come to the usage too, you can see that out of the 150, we use 32.33. Here, that's for the flour. We use 32 out of the 150. For the sugar, we use everything. That's 105 out of the 105. For the egg, we use 31.33 x out of the 36x. And for the time, we consume everything. The 180, that's the 3 hours. We consume everything. So, yeah, and these are sensitivity reports. So you can see our final, these are cell. For the one that I'm using, I'm not using Excel. So here, the names are not there. But when you're using Excel, you see the names, everything will be here. Yeah. So this is a sensitivity report. And then this is the profit, the 333.33. This is our profit. Yeah. So for the sensitive report, sensitivity report, we will explain this, or we have another video about this where we will go deep into analyzing this, what it means, the allowable increase, allowable decrease, objective coefficient, the reduced cost, final value, everything, the shadow price, everything. So we explain everything into details in our next video. So this is how we represent, or this is how we solve our linear programming using the Excel, right? Yeah. So that's it. Good day.